Hello everyone, this is Taylor walking through question 6 of the Spring 2019 MAS1 exam. Let's get started. You're given the following information. 1. The severity of each theft loss in a homeowner's insurance policy independently follows an exponential distribution with mean 2000. 2. The insurance company only pays the amount exceeding the per loss deductible. 3. The sigma sub j is the standard deviation of the amount the insurance company pays per theft with a deductible of j. Calculate the absolute difference between sigma sub 1000 and sigma sub 500. For this question, it's actually really similar to question 3 of the same exam, if you want to refer to that video for reference. So it boils down to really knowing this formula for compound frequency severity distributions. So definitely need to know this formula. Second, whenever you see deductibles and exponential distributions, chances are you're going to need to use this knowledge that exponential distributions are memoryless. So definitely need to know that. And then finally, that the variance of a binomial distribution is p times 1 minus p, or probability of success times probability of failure. The one interesting thing about this question, or a way in which it differs from question 3, is in this third bullet point. So in question 3, I believe it was per unit of time, so something like claims per day. But this is interested in what the company does per theft. So a theft can either reach and pass a deductible or not, but it's just kind of an interesting different way of thinking of these problems, that instead of a unit of time, you're looking at things as per theft. And that's why we have this binomial distribution popping up, because we're going to be looking at, for a given theft, what's the standard deviation of the expected payment that the insurance company is going to have to make. So jumping into the calculations that prep into that larger variance formula, for frequency, what we're looking at is what is the probability that you surpass the deductible amount. So all we're doing is doing 1 minus the CDF of the exponential distribution, where theta is 2000 because that was given, and in this case the deductible is 1000, so we plug in x equal to 1000. That's how we get the 60%. Next we do the exact same thing, but where the deductible is 500, and that's how we get this 78%. So that's it for frequency for now, and then for severity, this is an exponential distribution, so it's just mean of 2000 and then variance 2000 squared. And this is where the memoryless property comes into play. So the mean and variance of the severity for both deductibles are the same, because once you look at the severity subsetting by those who got past the deductible amount, it's memoryless, and so you keep the same mean and variance. So finally, we just take all those values and plug and chug into this larger formula. So to walk through the $500 deductible, this is going to be that probability that a claim goes past the deductible amount, so that's that expected frequency, multiplied by the variance of severity, so 2000 squared, plus the variance of the frequency. So it's binomial, so the variance is just p times 1 minus p, so that's what's going on here. And then finally, we want the mean of the severity squared, so that's just this 2000, and then that quantity needs to be squared. And that finally results in 1950.46. We then repeat the exact same calculation, but for the deductible of 1000, that's how we get 1838.67. And then we subtract the 2 to get our final answer of 111.8. 111 falls in the range specified by D, and so D is our final answer. Thank you for watching this walkthrough of question 6. Please consider subscribing if you find these videos helpful. Thanks. Have a good one.